Hey, my friends. We're friends now, aren't we? Like, I'm your friend. You see me on the street someday, say, hey, friend. Okay, that'd be a little creepy. Anyway, my name is Mr. Krause. Hopefully you know that by now. Mr. Krause. My partner in crime is Miss Newman. We are NKinfinity.com. All these videos can be found nicely organized at nkinfinity.com, or your teacher could just link to them. A little itchy nose. Today I will be Mr. Key. Once again, if you've been watching my videos, you know I'm always Mr. Key. Stands for Mr. Krause, but Mr. Key's better. Alright, we're just going to get started. Today we're going to be solving radical equations. Yo, that's radical, man. That's like totally radical. We're going to be solving some radical equations. Alright, so what were you going to do if you were going to solve this equation? I mean, clearly the answer is x equals 10. Not exactly. Remember, it's plus or minus 10, because isn't negative 10 squared 100? And positive 10 squared 100. So, yeah. And in ninth grade, you probably would bring the 100 over. You'd say x squared minus 100 equals 0. You'd factor this baby. You'd go ding-da-ding-da-ding. You'd say x, and then minus 10 and plus 10. You'd say, oh, x is equal to 10, and x is equal to negative 10. Something like that. Well, I like to solve it a slightly different way. What I would like to do is I would like to just take the square root of both sides, because we just learned that the square root of x squared is just x. And I would take the square root of this side. But you need to learn something. When you take the square root, you put a plus or minus. Anytime you're going to take the square root and you're going to solve it this way, you have to remember to put the plus or minus. Now, will you get annoyed with me by the end of the day how many times I'm going to say that? Yes. Do I care? Absolutely not. I don't care. And you can solve it just like that. Instead of going through all this work, you can just do it that way. So how's that going to look when we start with problems like this? Woo. So we're going to do the same thing. Now, I could take this thing, double distribute it all out, clean it up, bring the 6 over, use the quadratic formula because it's not going to be factorable, I'll tell you that right now, and then solve it. You know, that would be a pain in the neck. Or I can simply just, I could do this. Let me just show you. X plus 2 times x plus 2 equals 6. This is x squared plus 4x plus 4 equals 6. Now, I'm really smart. I can do this pretty quickly. And this I get x squared plus 4x minus 2 equals 0 when I bring the 6 over. This is not factorable, so I have to use the quadratic formula. B, C, D. I know you might have learned this in ninth grade. I don't even remember. You may not even know what the quadratic formula is. But this is the quadratic formula. It's negative 4 over 2 times A. Plus or minus. Now I'm really good at this stuff, right? Oh, A is 1, B is 4, C is negative 2, and then D is really B squared minus 4AC. You're probably all going, what is he talking about? But that's okay. Sometime during this year, we will talk a lot about the quadratic formula and be doing some work with it. B squared is 16 minus 4 times 1 times negative 2. This is really plus 8, so this is 24 over... Oh, this should be just 2 times 1 over 2 times 1 again. So this gives me x equals negative 4 over 2 plus or minus the square root of 24 over 2. Now, if I simplify the square root of 24, I'll do that in blue. That's really equal to the square root of 4 times 6. This is really 2 square roots of 2. So what I have here is x equals negative 4 over 2 plus or minus 2 square roots of 6 over 2. Now I can simplify it, and I get x equals negative 2 plus or minus. Those cancel, the square root of 6. And there's my answer. Okay, I'm really smart, and I did that pretty quickly, and I got the right answer, and I didn't make any mistakes. Let's do it a slightly different way. Let's see if we can arrive at the same answer. So there, I'll just leave this here. I'll leave it way down here. I'm going to see if I can do this a slightly different way. I'm just going to take the square root of both sides. I'll use purple because purple's cool. Oh, went too far. Take the square root, and when you take the square root, you put a plus or minus. So I end up with x plus 2 equals plus or minus 6. Oops, square root of 6. Subtract 2. Subtract 2. And I get x equals negative 2 plus or minus the square root of 6. Same answer? You betcha. But, that was a little easier, I'd say. So, that's an easier method to solve problems. I mean, if you don't have to go through all that other work. Sometimes you do. Sometimes you have to. But not all the time. All right. Where are we? Oh, I got to minimize this a little bit. We're going to the chart of inverses. This is why I teach math, because I don't have one of those radio voices, because that would be really cool if I had a radio voice. So I'll fly through these, and then we'll just keep talking. What is the inverse operation of addition? Subtraction. What is the inverse operation of multiplication? Now, these should have almost double arrows on these two, because the inverse operation of subtraction is addition. The inverse operation of division is multiplication. What's the inverse operation of something that's squared? Square root. What's the inverse operation of a square root? Squared. Now, I could have just put a double arrow here. Double arrow here if I want to. Inverse operation of something that's cubed, cubed root. Next year, I think I'm just going to put double arrows. And the inverse operation of a cube root is to cube something. Why am I telling you this? I am so glad you asked. Oh my God, I'm like, please ask, and you ask. Oh my God, you guys are awesome. So, hey, yo. I had to go there for a second. So, I'm glad you asked. I'm so excited. Something happened there. Okay, I'm so excited you asked because we're going to talk about it. We're just going to use that information to solve radical equations. Now, somehow my box here got over things, but this is just steps. All right. Get the weird thing alone will be our first step. You'll start to recognize that's a theme throughout the year. Get the weird thing alone, but we'll be talking about that. Undo the weird thing. However you have to undo it by taking its inverse. Solve for x. Check for extraneous solutions. This is going to become a key. You must check these for extraneous solutions. What does extraneous mean? Wrong answers. Bogus solutions. Answers that arise by using this method. Sometimes things arise or answers arise that are not correct. And you'll see how that works and plays out as we get going. All right, so let's move. Let's rock and roll. These aren't too difficult. So the weird thing in this case is the radical. Is it all by itself? Yes, it's all by itself. I don't have anything to do there. Great. It's a square root. What is the inverse operation of a square root? It is squared. So we square both sides. So I end up with x minus 5 equals 16. Now solve for x. Add the 5, and you get x equals 21. You should check your answers. 21 minus 5. That's the square root of 16, which is 4. And it works. Yay! 3's done. Bodied. That's what the cool kids say. I'm cool. Now, in this case, the weird thing is not alone. Again, the weird thing in this one is this radical right here. We want that to get all by itself, to be all by itself. So we're going to subtract this 2. We're going to subtract this 2. So now I've got radical x plus 3 equals 4. Now we have 4 again. That's weird. Now we have the weird thing alone. So now I'm going to go through and I'm going to square this side. And I'm going to square this side. A square and a square root, poof, cancel each other out. So I end up with x plus 3, equals 16. Or x equals 13. Let's check our answer. You must check all radical answers. I'm telling you, like this one's easy, right? But oftentimes they're not so easy and they're not so obvious that they work or don't work. This is the square root of 16 plus 2. Does it equal 6? This is 4 plus 2. Of course it equals 6. All right. It's not going to happen all the time, kiddies. All right. Is the weird thing alone? Oops, my hand just moved that. Is the weird thing alone? Well, this is the weird thing right here. That's the weird thing. We got to get the weird thing alone. So this 3 cannot stay here. It has to go. So we're going to get rid of it. Divide by 3. Divide by 3. And I get square root of x minus 4 equals 4. Okay. If you're wondering, 4 is not my favorite color. Or number. It just keeps coming up. I don't know why. She swallowed the fly. I guess you die. We'll square both sides. Square both sides. I get x minus 4 equals, guess what? 16 again. X equals 20. Check your answer. 3 square roots. Always go back to the original problem. 20 minus 4 equals 12. This is 3 times the square root of 16 equals 12. 3 times 4. Bam! Checks. If this one's 4, I'm throwing the pen down. Oh, yeah, baby. Starting to get more difficult now. Again, is the weird thing alone? In this case, this is the weird thing. It is. It's all by itself. Now, you have to be careful here, children. Wow. We have to be careful. So, here we got. We're going to square this entire right side. But if I square the entire right side, I also have to square the entire left side. Notice how I put it in parentheses. How I put these other ones in parentheses? See how I put this one in parentheses? I hope I did that in all of them. I sometimes get in a bad habit because I do things in my head. See, I put that one in parentheses, and I put that one in parentheses right here, right? Every time I'm going to square a side, whether it's a single number or not, I get in the habit of putting things in parentheses. And this is the reason why. If you just tried to square that left side and wrote down x squared plus 1 squared, right, you'd be wrong. Can't do that. You have to square that whole side. Now, the right side's easy, but the left side, squared really means you have to write that as a binomial times a binomial. You have to write it like that. So it's very easy not to make that, or it's very easy to make that mistake. And when I remember not to make a mistake, I drink my Dunkin' Donuts coffee. They're sponsoring us. Just kidding. The only sponsor I have is, well, you. You're my sponsor. Hi, sponsor. So anyway, we're going to square this side. We're going to write it twice, and we're going to double distribute, okay? Now, please don't be that person that says, oh, the squared goes there, the squared goes... You don't distribute a squared. A squared means you write the thing twice, and you do the math operations. On this side, the square root just cancels. All right, so on the left side, I end up with x squared plus 2x plus 1 equals 7x plus 15. I don't go through double distributing, kids. By now, if you can't double distribute, we got other issues, okay? You multiply the x by both of these. You multiply the 1 by both of these. This is 1x, and this is 1x. That's 2x's, okay? I hope by now you can double distribute. All right, everything's coming. Whenever you have a quadratic, everything has to come wherever the x squared is, as long as the x squared is positive. So we're going to subtract 7x, and we're going to subtract 15. So I get x squared minus 5x minus 14 equals 0. Now I'm going to factor. Oh, yeah, baby, the first factoring of the year. Actually, in my class, we go through what's called factoring boot camp for the first 3 days. We just factor. Because I want to make sure my kids can factor. And I test them on factoring, and I'm a factoring fanatic, freaky guy, man. I love factoring. This is x, and this is x. We're going to use -7 and +2. So my two answers are x equals 7 and x equals -2. You must check your answers. I have two answers here, but I'm not sure if both of them work. Up until now, everything's worked, but now, especially when you get two answers, oftentimes one will not work. And we're going to check in black just because it's cool. I said it's cool. So we're going to try the 7. So 7 plus 1. Does that equal the square root of 7 times 7 plus 15? Well, this is 8. And this 7 times 7 is 49. 49 plus 15 is 64. The square root of 64 is 8. So I get 8 equals 8. Catching! Yeah, that one worked. All right, moving on. Let's try -2. -2 plus 1. I'm already sensing a problem here because on the left side, I'm going to have a -1. And I don't really think I can take the square root of something and have a negative. Let's see what we got here, though. 7 times -2 plus 15. This equals the square root of, let's see, 7 times -2 is -14. -14 plus 15 is 1. The square root of 1 is 1. Does -1 equal, whoa, that's behind my back, isn't it? So all I did was plug in the -2. -2 plus 1. 7 times -2 plus 15. 7 times -2 is -14 plus 15 is 1. So this is the square root of 1. Does -1 equal 1? No. So -2 is what's called an extraneous solution. So you must get rid of it. So the only answer here is 7. Again, -2 is called an extraneous solution. And what happens is sometimes when you use solutions like this, you end up with solutions like this, when you do this way of solving things, you introduce extraneous solutions, and you got to learn to get rid of them. All right, that one's gone. All right, let's keep going. Come on with your bad self. All right, we got to isolate the weird thing. We got to get the weird thing alone. The weird thing is right here. So we got a lot of stuff to get rid of. First things first, you always take care of adding and subtracting first. So we're going to add this 4 and add this 4. So we get 2 square roots of x plus 3 equals 12. You still don't have the weird thing alone. Again, this is the weird thing. The 2 has to go. So we're going to divide by 2. Divide by 2. And now I get the square root of x plus 3 equals 6. Okay, I'm going to square both sides. So I get x plus 3 equals 36. I'll subtract 3, and I get x equals 33. Don't forget, you need to check your answers. So we're going to go 2 square roots of 33 plus 3 minus 4 equals 8. Well, this is 2 square roots of 36 minus 4 equals 8. That's just 6. So 2 times 6 is 12. 12 minus 4 is 8. Catching. Bless me. What is this? We now have a cube root. We now have, it took me forever to say that. We now have a cube root, not a square root, a cube root. And in order to get rid of a cube root, you have to cube. So if I cube that side, I got to cube that side. So this leaves me 2x plus 7 equals 27. All right. Subtract 7, I get 2x equals 20, or x equals 10. Check your answer. The cube root of 2 times 10 plus 7 equals 3. So this is the cube root of 27 equals 3. And yes, the cube root of 27 is 3. Oh, that was fun. Next page. Oh, my gosh. Oh, it's on this page. My answer key's on the next page. All right, here we go. Isolate the weird thing. Get the weird thing alone. I'm going to say it a million times. I know you're going to get tired of it. I don't care. So we got to isolate the weird thing. We're going to bring the 9 over. So I get the cube root of x is equal to 8. Now, to get rid of a cube root, we just cube it. Cube and cube. So the cube root of x cubed is just x, and 8 cubed is 512. Is that right? Oh yeah, baby. So now I come over here and I say, oh, the cube root of 512 minus 9, does that equal negative 1? Well, this is just 8 minus 9. Does that equal negative 1? Negative 1 equals negative 1. Ka-ching! All right, still got to get the weird thing alone, so I'm going to get rid of this 2. So I get x minus 3 equals 2. Square root. Now square both sides. And I get x minus 3 equals 4, or x equals 7. I'm going to spade a time. It works. All right, so here we go, kids. Let's see what we have here. We have a square. We're going to solve equations with rational exponents. Rational exponents. All right, so square root. In order to get rid of a square root, we square it, and we end up with x to the 1. Now, that's probably confusing to you because this cancels and this cancels, and leaves me x to the 1. But isn't x to the 1 really just x? So we've already talked about that, right? So what we really have here, and what you don't know is what we have here is we really have an exponent raised to an exponent. You just don't know what the exponent for a square root is. And that's what you're going to be introduced now. 1/2 is the exponent for a square root is 1/2. So x to the 1/2 is really equal to the square root of x. They are equivalent. The cube root, x to the 1/3, is equal to the cube root of x. So why does that, let's see how that works. So if x to the 1/2, so if I take x to the 1/2 here and I raise it to this, when you have an exponent raised to an exponent, what do you do with the exponents? You multiply them. So what is 1/2 times 2? It's 1. So this is really just equal to x. So that's why this works. That's why this works. So rational exponents, let's say I have any rational exponent like a over b. I don't care what a over b is, it doesn't matter. I'm going to raise it. Oh, that's what this is for. Raise the rational exponent to the reciprocal. So if I have a over b, I'm going to raise it to the b over a. Now, the reason I do that is if I multiply those, oh, I don't have to do this. The a's cancel, and the b's cancel, and they just make 1. So I end up with x to the 1, or just x. Now, you're going to see how that's going to come to play right now. So, rules still apply. You have to get the weird thing alone. There's the weird thing. We're going to get that all by itself. X plus 2 raised to the 3/4 power equals 8. But the only way to get rid of this 3/4 right here is to raise the left side to the reciprocal. So I'm going to take this whole thing right here and raise it to the 4/3 power. But if I raise that side to the 4/3 power, I have to do the same to this side, 4/3 power. Now, you need this, I don't, but whatever. 4/3 power. These three, let me get my black out. These 3's cancel. These 4's cancel. And I end up with just x plus 2. Now I'm going to talk to you about rational exponents because I think it's important that you understand these. But let's just go over to the thing. Let's go over to my I don't know why. Let's just do that. All right. So I want to come over here and I want to do 8 raised to the control division 4/3 power. And you're going to find out this is 16. So I come back to my thing here. This is equal to 16. Now, I want you to know why this is equal to 16. In the denominator, we'll talk about this more this year, but in the denominator I have a 3. This is a root. In this case, it's a cube root. In the numerator, you have a power or exponent. Okay, that's we're going to raise that to that. So what I really have here is the cube root of 8 raised to the 4th power. That's what this means. Roots, by the way, here's the ground. Roots are in the ground. Power up. Power up. Power up, kids. Power up. And roots are in the ground. So I always try to remember the roots are in the ground. So you can always use your calculator, but I want you to start to understand what rational exponents mean. Roots in the ground, power up on top. So the cube root of 8 is 2. 2 to the 4th is 16, and that's why the answer is 16. So I end up with a final answer of x equal to 14. I won't waste your time. It works. Let's keep going. Isolate the weird thing. Get the weird thing alone. You still got to do that. Divide by 3, and I get x to the 3/2 equals 125. We're going to raise it to the reciprocal, 2/3. But if I do that side, I got to do this side. Now, I'm going to not use my calculator because I want you all to practice this. 2/3 and 3/2, they cancel each other out, and I get x. Now, remember what this means. You got a 3 in the denominator. That means a cube root of 125, and the 2 is the power. So the cube root of 125 is 5. 5 squared is 25. Now, I could have used my calculator to figure that out, but I choose not to. All right, here we go. We're going to raise this to the reciprocal. The reciprocal of this is 2 to the 5th. And so we have to raise this to 2 to the 5th. So the 2 to the 5th and the 5/2 over here cancel, so I end up with x plus 3 equals. Now, again, we're going to practice this. This is the 5th root of 32 squared. Well, the 5th root of 32, 2, 4, 6, 8, 2, 4, 8, 16, 32. 2 to the 5th is 32. It should be obvious. It's 32. It's even. It's going to be 2. So this ends up being 2 squared or 4. And so I end up with x equals 1. By the way, you want to check it? Check this out. We're going to do 1 plus 3 to the 5/2. Does that equal 32? Well, this is 4 to the 5/2. Okay, well, what does 5/2 mean? 5/2, 4 to the 5/2 means square root of 2, square root of 4. The 2 goes here, square root of 4 to the 5th power, or 2 to the 5th. And we just satisfied that that was 32. All right. Isolate the weird thing. Get the weird thing alone. We're going to divide by -2. We're going to divide by -2. And I get x to the 3/4 equals 8. Now we're going to raise it to the reciprocal, 4/3. Now, at some point, you're going to get good at this, and you're just going to realize what that is. The denominator is the cube root. So what is the cube root of 8? 2. 2 to the 4th power, 16. All right, I got 2 problems left, kids. 15 and 16. All right, so 4/3 power. We're going to raise this to the 3/4. We're going to raise this to the 3/4. Over here, I get x minus 5, because these cancel, equals. Now, let's see. It's either got to be 2, 3, or 4. What do you suppose the 4th root of 81 is? Of course, it's 3. And 3 cubed is 27. Now, again, you can always come over to your calculator and go 81 raised to the control division 3/4, and you'll find out it's 27. You can always do that. But you as a student needs to start recognizing what that means and start using that cranium, that gray matter, for more than growing hair. See what happens, though? So you still want it to grow hair. See, I stopped. I just started using it just for math, and look what happened. So you don't really want that, but it's okay. And I get x equals 32. Last problem, baby. Let's subtract the 4. We'll bring it over. We end up with x plus 2 to the 2/3 power equals 4. We're going to raise it to the reciprocal. The reciprocal is 3/2. And I end up with x plus 2 equals, now remember, this is a square root. It's a square root. So what is the square root of 4? 2. Cubed is 8. Subtract 2, and I get x equals 6. And just for fun, because we should check one of these, we're going to check this. I'm going to just check it using my calculator. I'm going to show you another method for checking these. So I'm going to type this into my calculator. Here's what I want to do. And I'll pick this one. So I want to type this in my calculator. I got this over here. I don't know if you can see it, though, very well. That was my answer. So I'm going to plug it into that equation. So first thing I'm going to do is store 6 into x. So 6, control var x, enter. And then I'm just going to type the original problem in. Parentheses, x plus 2, parentheses, raised to the, it's a fractional, it's a rational exponent, 2/3, 2/3. Get out of all that exponent mode, plus 3. And hopefully it's 7. Pacham! Wow, kids, oh my God, that was so much fun today. All right, that's it. That's all she wrote. That's the rest of unit, oh, that's only 2.6. That's only 2.6. We got one more to go, and this unit is over. All right, kids, goodbye. See ya.